Hello all, here is your new video 3.1 solving systems using graphing. I have a new feature where you can see my face. So I thought that you might want to see me as I teach because I'm such a good looking fellow. So anyways, here we go. Here's your title for today. I'm going to be using this lightsaber as a laser pointer today. So today's title, 3-1, Solving Systems Using Graphing. Now, what is a system? A system of linear equations is a set of two or more equations. We're going to probably mainly focus in on two equations, but you could certainly have three or four or as many as you'd like. Solutions are ordered pairs that happen to work in both, or if there's more than two, all of the equations. So sometimes you're going to be graphing, in fact, most of the time you'll be graphing, and you'll graph this blue line and you'll graph this red line, and they will intersect at one point. That one point is the one solution to this system. And remember, a system is two or more lines. What does the solution mean? Well, the solution means that this ordered pair, whatever x, y that is, that works in both the blue and the red equation. These are going to be rare. We're going to talk about these mainly in class, but sometimes you graph two lines and they're parallel lines. For example, their slopes are the same. When they're parallel lines like this and their slopes are the same, but they have two different y-intercepts, they will never cross. So these are said to have no solution, no intersecting point. And then sometimes the two lines happen to be the same line. They may not look like it when you first started graphing them, but as you graph them both, this red and blue line lie on top of each other. So we say they have infinitely many solutions, which means that mainly they cross here, 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 here. Going back to example 1a. Here's example 1a. Now, I'm going to be giving you graph paper. Hold on a moment. All right, here we go. Now I'm back again. I see my face there again. I had to add that to each slide. Okay, so now when you're doing this in your notebook, well, as you're writing down example 1a here, the thing you're going to want to pay attention to is you're going to want to pay attention to trying to do your best to make these graphs as beautiful as possible. So right now when you're doing your own graphs inside of your notes, you're going to draw your x and y axis as clean as possible. You might want to use a straight edge. During class, I'm going to give you a lot of graph paper for this, and you're going to want to make these hash marks consistent so that the distance between them on the x and y axis is about as equal as possible. As you're graphing these, if you don't do that, things are going to really mess up. And I'm going to do the best to draw straight lines with this little iPad tool I've got here, this little stylus, but it's not going to be a beautiful line. I don't have a beautiful line tool like I do on the smartboard. There are lots of ways to graph lines. You can select whichever way you want. Now, personally for me, this one's so easy to get into y equals mx plus b. I'm just going to move that 2x to the other side. So subtract it to both sides, that I can do this line very easily. Y equals negative 2x plus 3. You go up to 1, 2, 3 on the y-axis, make your dot, and then you're going to go down 2 over 1. Now normally I'd really suggest you only need to make one dot and draw your line, but this problem, as you do this whole lesson, it's going to be more helpful to continue this pattern down 2 over 1, down 2 over 1, down 2 over 1. And even if you want to, go backwards, you could go up to left 1 if you wanted to. Now here is where I'm going to do my best to draw this line as straight as I can. Okay, it's about as good as I can do on an iPad. Now for the second equation, the red one, you certainly can minus the x to both sides and divide by 2, but this is in standard form, so I'm just going to do it by intercepts really quickly. If I substitute a 0 in for x, I get 2y equals negative 10, and divide by 2, I would get negative 5. Now, if you put that in slope-intercept form, you'd get the same thing. And then if I put a 0 in for your y value, a 0 in right there, 2 times 0 is 0, you get x equals negative 10. So you get negative 10, 0. Now that might be a little bit more complicated to graph, especially if you have to go 10 to the left, but let's see if I have enough room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's way on the edge here. and 0, negative 5, 1, 2, 3, 4, 5 is right here. And I'm going to do my best to draw this line. Now, if you chose to do this by y equals mx plus b, you absolutely can by subtracting the x to y equals negative x plus, minus 10. And then you can divide by 2. Don't forget you have to divide everything by 2. This may be of benefit in this lesson because the slope helps you count multiple points. Notice how the y-intercept is still the negative 5, but my slope now is down 1 over 2. So if I go down 1 over 2, down 1 over 2, down 1 over 2, these lines are going to cross. I'm doing the best I can. See this blue one? I don't know if I extended it far enough, so I might need to adjust. Down 2 over 1, down 2 over 1, down 1 over 2, down 1 over 2, down 2 over 1. Now, this is a complicated one. I'm going to change them to black here because I'm not really sure where these lines cross. They cross right about there. If I connect this and make it a little bit better, I'm not exactly sure, and this is why it's going to be vital in class that you use a straight edge when you do all this. But these are just sketches, so I'm going to estimate this coordinate. Right now, we're just going to kind of talk about what graphs do and how they look, but next lesson, you're going to be able to get this exact perfect ordered pair. I don't know what this is. Let's see. 1, 2, 3, 4, 5. It looks like it's between 5 and 6, right? I really have no idea. I'm going to go 5.5. And then the y value is down 1, 2, 3, 4, 5, 6, 7, 8? I don't know. I'm going to go 7.5, but it's down, so it's negative 7.5. These are all just estimates. So we're going to have to do our best as we go through all this, and I'm okay with this answer for now. Whoops, I went too fast. Okay, so now this one here, you might want to pause and give it a try and see if you can graph this blue one and this red one. A little hint on this red one is in point slope form. So you can certainly manipulate it if you want to, but I'm just going to use the point and the slope to graph it. But completely up to you. Give it a try, pause, and then I'll start working on this as you come back. This first one, y equals negative 5x plus 3, has a y-intercept of 3 and a slope of down 5, 1, 2, 3, 4, 5 over 1. I'm going to do a couple, down 1, 2, 3, 4, 5 over 1. Looks like that. Doing my best to draw a straight line on this iPad. And then the red one, now with the red one, the point is right here, but remember, because they're in parentheses, you have to flip the sign. So the point is 1, negative 7, and the slope is down 5 over 1. So 1, negative 1, 2, 3, 4, 5, 6, 7, 1, negative 7, and then down 5, 1, 2, 3, 4, 5. It's off the screen over 1. Let's go back. Up 1, 2, 3, 4, 5 over 1. This is interesting. Looks like these guys will never cross. I think they're parallel. Let's analyze the slopes. Lo and behold, they are parallel. These will never cross. No solution. Remember, no solution is what you say when the lines never cross, if they're parallel with different y-intercepts. And by the way, if you really wanted to, you could distribute this in and get negative 5x plus 5 equals y plus 7, and then subtract 7 to both sides. If you wanted to, I'm running out of room here, you get y equals negative 5x minus 2, and that's still this red line. All right, one more. Now for this one, you're going to do the same thing. Figure out and give it a try if you'd like to pause. I'll start setting it up. Now, you got to be careful here. You have to divide by 4. Divide by 4. When you divide everything by 4. Y equals negative 1/4 x. And then 4 over 4 is 1, but it's a subtraction, so it's minus 1. The red one. Bring over the 1/4 by adding it. And you get careful here. This is a tricky one with a negative y equals 1/4 x plus 1. But this is like a negative 1, so you have to divide. I'm going to go over here for my final answer. Y equals, these cancel, 1/4 divided by negative 1 just flips the signs. And then 1 divided by negative 1 is minus 1. So now before I even decide to graph these two, let's think about it for a second. You know what? Can you figure out what's happening here? You certainly can, hopefully. Y equals mx plus b, y equals mx plus b. If I graph the red one, I go down 1, make a dot, y-intercept. Down 1 over 1, 2, 3, 4, make a dot, draw my line. And if I change to blue, down 1, make a dot, down 1 over 4, make another dot. They're on top of each other. They coincide. They're the same line. Infinite many solutions. Okay, so that says infinite. It gets a little sloppy here on the iPad. This is your lesson. This is how it all pretty much goes. It should be pretty easy. Thanks for listening, and we'll see you in class.